Hello everyone. Okay, so in this video we're just going to be looking at some exam questions for the general trig graph. So our first one up is from 2021. It's from paper 2, question 9b. So the voltage Vt in volts of a certain alternating current is given by the function 110 root 2 sine 120 pi t, where t is in seconds. Find the period and the range of the function. Well, I see a pi here within my angle. So this is going to be in radians, right? So find the period and the range of the function. So first of all, the period, if you recall, is equal to 2 pi divided by c. So it's going to be 2 pi divided by 120 pi, because that's what c is equal to here. And that is going to be 1 over 60. So the voltage, so it's like kind of it's like increasing, decreasing, and it's electricity. It's really fast. So it completes one cycle in like 1/60th of a second. It's like, you know what I mean? It's like really fast, right? Then the range. So remember, the range is just my maximum point and my minimum point. Well, looking at my graph here, so we're going to recall map. So midline, amplitude, and then period. So midline, I don't have anything from a midline. I don't have anything. I know my amplitude is going to be 110 root 2, but I don't have anything from a midline. So my midline is going to be a is equal to 0. Because remember, we use this function a plus b cosine c x, and there is no a. There's no letter here that corresponds to a, so a is equal to 0. So my midline is 0. So my range is going to be my midline 0 plus my amplitude, which is 110 root 2, and 0 minus 110 root 2, which is 110 root 2 and minus 110 root 2. There's my period and there's my range. So sketch the function for 0 till 0 to p, where p is the period of the function, and Vt indicate the period and range on the function on the graph. So we want to sketch out that function now, where in the domain 0 to 1 over 60. So you might be thinking, oh my god, that's like really small. How are we going to do it? So best way to remember is always go up in quarter periods, right? So go up in quarter periods, because that will help us get all the kind of key points on the graph. So I'm gonna take out my ruler here. Bing. Ding. Baboosh. So I'm gonna say 1, 2, 3, 4, 5. I'm going to say 5 blocks or 5 units down is minus 110. That's my minimum. 1, 2, 3, 4, 5. This is my maximum. So let's go up in quarter of periods. So a quarter of my period, which is 1 over 60, is going to be 1 over 240. So, right. So sorry about that. So we need to go up in quarter of periods. So we need to go up in 1 over 240s. So my values are going to be 0, 1 over 240. Add on 1 over 240, that's going to be 1 over 120. Then add on another 1 over 240, remember. So I'm not adding 1 over 120. We're going to add 1 over 240. So 1 over 120 plus 1 over 240 is equal to 1 over 80. And then finally, if you add one more 1 over 240, you should get 1 over 60. So I'm going to find all of these points and put them on my calculator. Or what I can remember is from this handy dandy table up here, where all my key points should be. So every quarter of a period, I reach a new thing. So it's midline, maximum, midline, minimum, midline. Every quarter period. So for this graph here, I know 0, well, it's a sine graph, so it's starting at 0. Again, you can put all these in your calculator and make sure it's in radians. Then after, so 1, 2, 3, 4, so 1 over 240, 1 over 120, 1 over 80, 1 over 60. So 0. My maximum coming here after a quarter of a period. My maximum's here. Half a period, I'm back in my midline. 3/4 of a period, I'm down to my minimum, and then I'm back up to my midline for a full rotation. And there you go. That is what my graph looks like, the volts. So again, you could do this and get your approximates from your calculator, but if you know the cycle of a trig graph, you shouldn't need your calculator for it. So use VT, find the voltage when t is equal to 6.67 seconds. Give your answer correct to 2 decimal places. Well, that's just calculator work. So if you remember, the function's equal to, so make sure you calculate in radians, because we're dealing with radians. So it's going to be 110 root 2 sine 120 pi times then 6.67. Make sure I close all my brackets. Click equals. I get V at the volts at 6.67 seconds to be 147.95 volts. I suppose that's the units I'm using. 147.95 volts. Then this one here, the final question here is actually a trig equation in disguise. So find one value of t for where the voltage is 110 volts. Give your answer in the form A over B. So I want to find when Vt is equal to 110. Well, I know Vt is equal to 110 root 2 sine 120 pi t equals, and then let it equal 110. I can divide both sides by 110 root 2. 110 root 2, and then my left hand side, these are going to cancel out, so I'm going to be left with sine 120 pi t equals 1 over root 2. Now I have a trig equation here. But my angle in here is in radians, so it's up to you what you want to do. You could convert this to degrees. So if you were to convert this to degrees, you will multiply the 120 pi t, multiply that by 180 over pi, which is equal to something big, like 21600 t. So you could have sine 21600 t is equal to 1 over root 2. And now we're dealing with degrees. Now you should still get the same answer for t, or we can just stick with radians. So it's only asking here for, it's just asking here for one value for t, where the volt is 110. So it's not even a proper full-on trig equation. It's only asking for one value of t. So honestly, we actually didn't really need to convert to degrees there. I was just being pedantic. We actually didn't really need to do that. We're not really dealing with a proper trig equation here. We only need to find one value, and how we could do that is by finding the inverse. So 120 pi t is equal to sine inverse 1 over root 2. So remember to make sure your calculator is in radians. And if your calculator is in radians, you should get the inverse of 1 over root 2 to be 1/4 pi. So 120 pi t is equal to 1/4 pi. Divide both sides by 120 pi. T is going to equal to 1/4 pi divided by 120 pi. Then I get t is equal to 1 over 408 seconds. So very, very, very small number there. Right. Let's look at this one now. This is a 2017 question. This is a bit of a tricky one. So, this one is a word problem where they gave us all the information and we need to be able to decipher the function from it. Sorry, I was getting my charger. Right. So the depth of the water in meters at a certain point in a harbour can be modelled in the function of this form. A plus B cosine ct. So it's saying here it's a cosine function, where t is the time in hours from the first high tide on a particular day. So t is the time from the first high tide of a particular Saturday. A and B and C are constants. Note ct is expressed in radians. On that Saturday, the following were noted. The depth of the water at high tide was 5.5 meters. The depth of the water at low tide was 1.7, and the high tide occurred at 2 a.m. and then again at 34 past 2 p.m. So what information are you telling us here? Well, this is going to be my maximum. This is going to be my minimum. And then this here, the high tide occurs at 2 a.m. and then occurs again at 2:34. But that's telling me my period, right? So that's telling me my period. And that is going to be 12 hours and 34 minutes. Or, we're dealing with hours, you see. So it's going to be 12 hours plus 34 over 60, which is going to be 12.52 hours. And that is my period. Use the information you were given to add as accurately labelled and scaled axes to the diagram below to show the graph f over a portion of that Saturday. The point P should represent the depth of the water in the harbour at high tide on that Saturday morning. So, I'm going to draw my y-axis in here. So this is the start of my graph. So we're starting my graph at high tide. That's what they said here in the question. T is the time since high tide. So when t is equal to 0, or when it's touching the y-axis, P should be my maximum. In this case, it's equal to 5.5. Right? Then down here is my minimum. So my minimum down here is going to be 1.7. So this is 5.5, this is 1.7. So I'm going to scale this as accurately as possible. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 boxes between 5.5 and 1.7. So each block roughly represents, each unit or each square roughly represents like half a centimeter. So we'll just go down like 4 of them here, right? And there you go. My x-axis is there. Right. So, what more information could I add here? Well, it's just actually it's just asked me to label the diagram. So there we go. There it is. I draw my y-axis, draw my x-axis, drawn my minimum and my maximum point. And I don't think I need to draw anything else for that question. Now, a thing that could help me now later on is the midline. So the midline is the line that's in the middle, which is just the maximum plus the minimum divided by 2. So 5.5 plus 1.7 divided by 2. Going to be 3.6. So my midline is going to be at 3.6, which is roughly going to be around here. there's my midline. Okay. So this is 3.6. Okay, find the value of A and B. Well, A is my midline, so A is going to be 3.6. B is my amplitude. So what's the distance from 3.6 to my maximum point? Well, it's going to be 1.9. And then this is a positive cosine graph because I'm starting at a maximum. So B is it's going to be 1.9. Bada boom, bada bing. Show that C is equal to 0.5, correct to 1 decimal place. So C, what do I know that has C in it? Well, I know the period is equal to 2 pi divided by C. And I know my period is equal to 12.52 up there. So with some algebraic magic, C is going to be equal to 2 pi divided by 12.52, which is roughly going to be equal to 0.5. So the first part of the question was actually not bad. Use the equation now, ft equals a plus b cosine ct. Find the times on that Saturday afternoon when the depth of the water was exactly 5.2. Give your answer correct to the nearest minute. So I want to find times on the Saturday afternoon. So we're going to be dealing past 12 noon and before like midnight. So I know my function is going to be 5.5 plus 1.9. Yep. 1.9 cosine 0.5t. That's my function, and I want to find out when my function is equal to 5.2. So I'm going to be finding a few values here for this graph. So I need to do one of my trig equations. So let me just simplify this all first. I'm going to have 1.9 cosine 0.5t is equal to 5.2 minus 5.5. Oh no, it's not 5.5. My apologies. This is my midline, which is 3.6. So 5.2 minus 3.6 is 1.6. Cosine 0.5t is going to be equal to 1.6 divided by 1.9. And I'm going to have here cosine 0.5t equals 16 over 19. Now, what we can do here is, if you're not comfortable working in radians for trig equations, we can change this to degrees. So if I change this to degrees, 0.5t multiplied by 180 over pi. Now, it's still honestly not going to give me anything nice. It's going to be 90 over pi t. So it's up to you. For me, if I'm working with degrees, but I still have a pi and I still technically a degree, it's just gonna hurt my head. It's gonna hurt my head. So I wouldn't really recommend it for that one now, to be honest. So I'm gonna stick with my radians. So I have my handy dandy little trig equation here. So to set them up, first I need to find out what quadrants it's in. So sex and the city. It is in positive, so it's quadrant 1 and quadrant 4. Yep. 2. I need to find my reference angle. So I'm going to say cosine or is equal to 16 over 19. Or is going to be equal to cosine inverse 16 over 19. Which is 0.57. 0.57 radians. Then I need to find now the two possible solutions. So I'm in my first and my fourth quadrant. So my first quadrant is just my reference angle. My second quadrant, remember, it's 180 minus or, but we're doing a radian, so it's going to be pi minus my reference angle. There's going to be pi plus my reference angle. And then this is 360 minus my reference angle. So it's 2 pi minus my reference angle. So my first angle is just going to be 0.57. So I'm going to have 0.5t is equal to 0.57 plus n2 pi. So remember, I have a general solution here. So n2 pi. I want to get t on its own. T is equal to 1.14 plus n4 pi. Because I multiply both sides by 2 to round up to 0.5, or you can divide everything by 0.5. It doesn't matter. So there's kind of my first general solution. I'm going to pull some questions out of. My second general solution. So my second solution here is going to be 2 pi minus 0.57. That is going to give me 5.713 radians. And then, so 0.5t is equal to 5.713 plus n2 pi. So my general solution here, multiply both sides by 2 or divide everything by 0.5. T is equal to 11.42 plus n4 pi. So now I have my two general solutions. Now I want to find out possible times now within the day. So to set up my little table here. Right. So my function here is 1.14 plus n4 pi. And then here 11.42 plus n4 pi. So when n is 0 and n is 1, I really don't think I'll need much more than that. So 1.14 plus 0 times 4 pi is going to be equal to 1.14. So hours. Here 11.42 plus 0 times 4 pi is going to be 11.42 hours. So after high tide, it will reach 5.2 meters in depth after 1 hour and after 11.42 hours. And then finally, when n is equal to 1, so 1.14 plus n is 1. So 1 times 4 pi, which is going to be 13.7 hours. And then here is going to be 11.42 plus 1, 4 pi. It's going to be 23.98 hours, or nearly a full 24 hours later. But you need to think of it now. So there are the times since first high tide. First high tide was 2 a.m. So I need to find now all these times. So 1.14 hours after 2 a.m. Is going to be okay, first I need to convert these times to hours and minutes, or I just add 2 to them, I suppose. So 2 hours to 2 a.m. plus 1.41 hours is going to be 3.14 a.m. Well, what's 1.14? 0.14. So get 0.14 multiplied by 60, you get 8. So 3:08 a.m. is my first solution. Then I'm going to have 2 a.m. plus 11.42 hours. 0.42 hours is going to be 11 hours and 25 minutes. So that is going to be 25 past 1 p.m. Is not value, that value, and then this value. And then finally 2 a.m. plus 13.7 hours. That's 13 hours and 0.7 minutes is equal to 42 minutes. So that it will be equal to 42 past 3 p.m. So we're looking for times in afternoon. So that's going to be 1:25 and 1:42 1:25 and 3:42 p.m. And that is the afternoon times where the depth of the harbour reaches 5.2 meters. Right, we just have like 3 questions left. So The diagram below shows the graph of the function sine 2x. The line and the line 2y is equal to 1. On the same diagram above, sketch the graph g of x, which is sine x, and 3 sine 2x. Indicate clearly which is g and which is h. So g is just a normal sine graph. So it's a normal sine graph. So at 0, I'm starting at 0. Then at my period is 2. So every quarter something interesting is happening. So at my first quarter here, this is my first quarter, I should be reaching my maximum. Then my next quarter, I should be back on my midline. My next quarter, I should be at my minimum, which is -1. And then I should be back here. There we go. There is my graph sine x. So, and then 3 sine 2x. Well, if you see here, my initial graph is sine 2x. So 3 sine 2x, it just means I'm increasing the amplitudes. Remember, b sine 3x. So this is my amplitude. So I'm just increasing or scaling it up by 3. So that'll be fine. My maximum point's here now. My minimum point here. My maximum point will be here. My minimum point will be here. So now this graph will look like this. Back up one more. There you go. And that's what that graph looks like. And this is graph H. Okay. Find the coordinates of point P in the diagram. So, if you care to see here, right, point P is this point right here. It's the point of intersection between this line and my function. So, I need to let these two equal each other. First of all, I need to get this line in terms of y. So y is equal to a half. So I'm now tasked to find where, find the coordinates where P, points P on the graph. So I need to find where my function is equal to a half. So I'm going to have here sine 2x is equal to a half. So let's solve for x. So x is in radians. So we'll work at degrees first. So we'll work in degrees first. So first of all, sex and the city. So I'm going to be working with a range up to 2 pi. And then my fourth solution, oh no, is it my fourth or my second? It's my, sorry, I can't tell with these graphs. 1, 2. If you can care to looky here, in the dotted line intersects the black line 1, 2, 3, 4. So it's going to be my fourth solution if from 0 to 2 pi. So sex and the city. So sine is positive, and so it's in positive in the first two quadrants. Next one, it's going to be 2x. Find my reference angle. So sine my reference angle is equal to a half. My reference angle is going to be equal to sine inverse a half, which is 30 degrees. Finally, find my two possible, find solutions for my general solution. So this is going to be my reference angle, 180 minus my reference angle. So my first solution is 30. So I have 2x is equal to 30 plus n 360. X is equal to 15 plus n 180. That's my first general solution. Then my next general solution, or 2, is going to be 180 minus 30, which is 150. So I'm going to have 2x is equal to 150 plus n 360. X is equal to 75 plus n 180. So it's asking me here to basically, I'm trying to find the fourth solution, or it's going to be i.e. the largest solution. And the largest solution, realistically, now I'm kind of cheaping out here because I only have, I'm doing this video now for like 30 minutes. I'm kind of cheaping out. But if I see here for this one, my largest solution is going to be there. Because look here, P is all the way over here. You know what I mean? So like it's going to be my largest possible solution. And my largest possible solution would be here when n is equal to 1. So when n is equal to 1, I'm going to have 75 plus 1 times 180. It's going to be equal to 255. Convert that to radians. So to convert to radians, we multiply by pi over 180, which is going to be 17 pi over 12 is my x value. So 17 pi over 12. So this p value here is going to be 17 pi over 12, and then y is equal to a half. So this is going to be, so y is equal to a half. So this, the y value is going to be 0.5. So that was a tricky one. Make sure to always double check your answer on your calculator. So let me just take out my calculator here, just double check my answer. So I'm dealing with sine 2x. So sine 2 times 17 pi all over 12. Close the brackets. And I'm going to get a half. So there you go. That is my largest solution there for that. Right. Let's look at now the 2023 exam paper. So Olga has some tests done to measure her lung capacity. When she is resting, the volume of air V in her lungs after t seconds can be modelled by this, where the volume is in litres and t is greater than 0 is time in seconds from a given point in time. Pi over 2 is in radians, so my angle is in radians. We're dealing with radians here. So find the max and minimum values. So the max is going to be my midline plus my amplitude, which is the absolute value of B. So 2 plus 0.4, which is 2.4 liters, is my maximum. My minimum is 2 minus 0.4, which is 1.6 liters. Gorge. Find the volume of air in Olga's lungs half a second after t equals 0. T equals 0.5. I'm going to get 2 minus 0.4 cosine pi over 2 times 0.5. Put all of that in my calculator and make sure that I am working in radians. So I'm just typing it in now. If you put that into your calculator, you get VT is equal to 1.717 liters. Right, so part 3 is asking us, so Olga's breathing is also measured while she's doing gentle exercise. During this time, when she breathes in fully, the volume of air in her lungs is 3.6 meters. So if she breathes in fully and the volume is 3.6 liters, well, I can take a wild guess and say that's her maximum lung capacity. When she breathes out fully, the volume of air in her lungs is 1.3 liters. So that would be her minimum value, or the minimum capacity of her lungs. Because just because we do a full exhale out doesn't mean we exhale all the air in our lungs. She breathes in and out twice as many times per minute while she's resting. right? So twice as many minutes. Don't fall into the trap of multiplying the period by 2, because I obviously didn't do that. So you have to think about, right, when you're exercising, right? So if she's just breathing normally, she's there, like, so that was one cycle, right? So like that was one cycle. But then when she's like, can we go for a little run? You're like, see how like my breaths have gotten faster? I'm completing the cycle faster. So therefore, my period, if I'm completing the cycle faster, my period is going to be shorter. So if my period's going to be shorter and I'm going twice as fast, I'm actually going now half of the period above the previous period. So if we scroll up here, the previous period here, we have pi over 2. So it was the coefficient of my last function there. So the old period is equal to 2 pi over c. In this case, c was equal to pi over 2. So put down your calculator, we'll get the old period is equal to 4. Therefore, the new period is equal to a half times 4, which is 2. So she completes a cycle in 2 seconds. Right? She completes a cycle in 2 seconds. So, now we need to use this information, write a formula for the volume of air in Olga's lungs during the time after she has breathed out fully. So after she's breathed out fully, we are measuring from her minimum, right? So we're measuring from the minimum. So there's my maximum, there's my minimum. So let's calculate a few things we need. Well, we need my midline. Midline is equal to the A. So midline is going to be my max plus min divided by 2. Which is going to be 3.6 plus 1.3 divided by 2, which is going to be 2.25, I believe. .45, and then my amplitude. My amplitude now is equal to the height from my midline to my maximum. So it's going to be my maximum minus A, in this case, which is 2.45 minus that's my midline. My maximum is 3.6 minus 2.45. I'm going to get here 1.15. And now just sketch it out a little bit for yourself, right? We're starting at Olga's minimum, right? So we're starting at the minimum here. So starting at the minimum, breathes in, breathes. There's my midline. What graph is this? This is going to be a negative cosine because I'm starting at her minimum here. So therefore B is going to be minus 1.15. So I figured out what B is. I figured out what A is, right? I need to figure out what C is. So to find C, we're going to use my period. So the period is equal to 2, which is equal to 2 pi over C. So we're going to have 2C is equal to 2 pi. Therefore, C is equal to pi. So I have A, have B, I have C. Let's sub it into my formula. So it's going to be 2.45 minus 1.15 cosine pi t. And that is the function ET we're looking for. So that's the new function there to measure Olga's breathing after she has breathed out fully. And let's move on to the next question. Then the last question here. The last question here is a Ferris wheel has a diameter of 120 meters. When it's turning, it completes exactly 10 full rotations in 1 hour. The diagram above shows the Ferris wheel before it starts to turn. It's no diagram, sorry about it. At this stage, the point A is the lowest point on the circumference of the wheel, and it's at a height 12 meters above the ground. The height h of the point A after the wheel has been turning for t minutes is given by this function. So this function, all the previous information, not important. We have my function. Complete the following table. Well, that's nice. Go to my calculator here. Go to my calculator. Open that up. So f of x equals to 72 minus 60 cosine pi over 3, and then t, but we don't have t, so we're going to use x. And make sure to put a little times there so it works. Then I'm starting at 0, and I'm going up to 8, and I'm going up in steps of 1. So I'm starting at 12, 42, 102, 132, 102, 42, 12, 42 again, and then 102. Draw this graph. This is a nice question. So 0, 12, 142, 102, 102, 3, 132, 4, 102, 5, 42, ding, ding, and then last bit here is here. So there you go. Oops, you didn't see it there, it's calculator, but there is my graph. Perfect. Find the period and range of ht. So we can use my graph, or we can use my function. If you want to use your graph, you can see here the cycle repeats itself every 6 minutes, right? So minimum, maximum, the cycle is repeating every 6 minutes. So from the graph, period is equal to 6 minutes, or if you want to use the function, period is equal to 2 pi divided by c. This case, c is pi over 3, and that is going to equal to 6 as well. And then the range is going to be my maximum point, which is 132, and my minimum point, which is 12. Easy peasy. During a 50-minute period, what is the greatest number of minutes for which point A could be higher than 42 meters? So, looking at my graph here, 42 meters. So let me just draw that here, purple. So it is above 42 meters, roughly 1.5, for roughly 4 minutes. For 4 minutes, it's above 42 meters. Now, we're looking at a 50-minute period. So we want to find out how many times does the Ferris wheel go around in 50 minutes. So 50 divided by 6 is going to be equal to 8 full cycles. Yeah. Plus a remainder of 2 minutes. So 8 full cycles it rotates. So if it does 8 full cycles, well, for 4 minutes of them 8 cycles, it's above 42. Now, if we're looking at the maximum possible height, maximum possible time it could be, we could take it like, what if he started observing at that point? What if the guy started observing here at this point right here? Well, I could say he was then above 42 for them full 2 extra minutes. So it's asking for the greatest number of minutes. So I'm going to add them 2 minutes on. So 32 plus 2, that's going to equal to 34 minutes. 34 minutes, possibly above 42. And then finally, by solving the following equation, find the second time that the point is at a height 110 meters after it starts running. So find the second time. So I only need 2 times for this. So when it's a height of 110 meters. So I'm finding when my function is equal to 110. So 72 minus 60 cosine pi over 3t is equal to 110 minus 60 cosine pi over 3t equals 110 minus 72. 110 minus 72 going to be 38. 38 divided by 60 is going to be cosine pi over 3t is going to be equal to 38 divided by minus 60, which is minus 19 over 30. Now I have my regular trig equation. Again, you could convert this to degrees if you wanted to, but again, it's just easier to work in radians. So sex and the city. So I am in minus, so I am in quadrant 3 and quadrant 2. Get my reference angle, so cosine my reference angle, ignore the sign, it's 19 over 30. My reference angle is going to be equal to cosine inverse 19 over 30, which is 50.7 degrees. Oh, degrees! I didn't put my calculator in radians. I'm such a fool. I'm a fool. Right, cosine inverse 19 over 30, 0.88. So 0.885 radians. Then I'm in the second and third quadrants, so it's going to be pi minus my reference angle and pi plus my reference angle. So I'm only finding two values here. So I don't need to do my general solution, I only need to find two values. So I'm going to have pi minus 0.885. So my first angle is going to be 2.257 radians, and then here is going to be my second angle is going to be 4.027 radians. And finally, we need to solve for t. So let my angles equal pi over 3. Pi over 3t is equal to 2.257. Pi over 3t is equal to 4.027. Divide both sides by pi over 3. So just put 2.253 and divide it by pi over 3. You're going to get time is equal to roughly 2.16 minutes. And this side here, you're going to get roughly, to divide 4.027 divided by pi over 3, you're going to roughly get 3.84 minutes. So it was asking here for the second time the value of t is above 110. So the second time is going to be 3 minutes and 80. So 3.84 minutes after you start looking. So that is the exam questions. This video is literally going to be so long. Can't believe I was talking for this long. I literally just taught an entire class. But anyway, it's fine. I hope this video was some help to you guys. And I'll catch you guys later. Bye.